Okay, my name is MOHD. This is for lab implement Etherchannel for lab 6.4.2. Okay, for the part 1 is build the network and configure basic device setting. Okay, this is for the device setting. We got PCA, switch 1, switch 2 and PCB. Okay, for part 2 is configure basic setting for each switch. For A is assign a device name to the switch. For go for switch 1 and then enable configure terminal, and for part B is disable this and lookup to prevent the router from attempting to translate incorrectly enter commands as though they were hostname. Okay, for S1 go for hostname S1 same as S2. Just change the name for as hostname S2 and then assign class as the privileged AZIZ encrypt password. Okay, for S1 no IP domain lookup, enable secret class. Okay, and then for assign Cisco as the console password in enable login, and then type client console 0 password Cisco login exit same as S2, and then for EU assign Cisco as the BTY password and enable login. Okay, then just type line BTY 015 password Cisco login exit. Okay, for F encrypt the plain text password. Just type service password encryption, and then create a banner that warns everyone accessing the device. Okay, just type banner MOHD authorized access only and exit. And then for I is set the clock. Okay, just type set clock question mark and then clock set question mark and then set time, set date and year. Okay, and then copy the running configuration to startup configuration. Just type copy running startup and exit. Same like S2. Okay, for part 2 is create VLANs and assign switch port. Okay, for the step 1, create VLANs on the switch. For A, on both switch, create and name the required VLANs from the VLANs label above. Okay, this is the VLAN 10, VLAN 20, 999 and 100, and name management, client, packet loss, and active. Okay, and then go for S1. Okay, configure terminal, LAN 10, name management, LAN 20, name client, LAN 999, name parking lot, and LAN 1000, name native and exit. Same like S2. And then B, configure an IP management interface on each switch using the IP address information in the addressing table. Okay, this is the interface assigned for LAN, and then go for interface LAN 10. This is for the LAN 10 management, and then copy the IP address was given for switch 1 and subnet mask. Okay, switch 1 192.168.10.11 and subnet mask 255.255.255.0, and then for the interface and then from C assign, okay, and then interface range F. Interface range is for the interface range. This is for the switch 1 and this is for the switch 2. Okay, and then we go for the switch port mode access and switch port access LAN 999 and shutdown. For S2, same like S2, just change the interface range only. Okay. Okay, for the step 2 is assign VLANs to the correct switch interface. Okay, assign use ports to appropriate LAN and configure them of the static access mode. Okay, and for the clients, for the VLAN 20, client needs switch 1 for F06. So go for S1 and then this type interface FA06 and switch port mode access switch port access LAN 20 and then exit, and for S2 is fast internet 018. This type interface FA0/18 switch port mode access switch port access LAN 20 and exit. And then for B issue, just show LAN brief comment and verify that the VLAN are assigned to the correct port. Okay. For switch 1, just type show LAN brief. Okay. For default is 0 and fast internet 0/1 to 0/6. For clients, active is for fast internet 06. For S20, for LAN 20, and for S2, you can see that clients use the LAN 0/18. Okay. Okay, for part 3 is configure trunk between the switch. For A, change the switch port mode on the interface to fast trunking. Use interface range. Okay, this is the interface range F001 and F02, and then go for the switch 1. This type interface range FA01 0/1 to 2 and in switch port mode trunk. Same like S2, interface range FA0/1 to 2 switch port mode trunk, and then we can we need to show the interface trunk. This is for, and then this type show interface trunk. This for fast internet 0/1 and /2 is mode is on, status trunking, sets as S2. And then for B, as a part of the trunk configuration, set relative LAN to 1000 on both switch. Okay, then go for the S1 and S2. Just type interface range fast internet 0/1 to 2 switch port net trunk native LAN 1000. Same like S2, and then exit. For the C, as another part of trunk configuration, specify that LAN 10, 20, and 1000 are allowed to cross the trunk. Okay, and then go for the both of switch, and this type switch port interface range F is 0/1 to 2, and this type switch port trunk allow and 10, 20, and 1000. Why is the length in spanning tree forwarding state and NASRUN entry different for F1 and F2? Yes. The answer is yes, because length in spanning tree forwarding state and NASRUN for fast internet 0/1, 10, 20, and 1000, and fast internet 02 is none. Okay, for part 4 is implement and verify an Etherchannel between the switch. Okay, for A, create a LACP based Etherchannel using F0/1 and F0/2 using group number 1. Okay, variable switch active negotiating the Etherchannel protocol. Okay, use the interface range. Then go for the S1. Just type interface range FA0/1 to 2 channel group for 1 to 6, and we choose 1, and mode for Etherchannel mode of the interface. Just type mode and question mark, and then you can see the mode which is active, auto, disable, on, and passive. In the question, we need to actively negotiating, and then just type active, and then we can see the creating a port channel interface port channel 1. Okay, seems like S2, and then after the internet is configured, okay, now create, and then for C, issue the show interface trunk. Okay, and then we just need to type is show interface trunk. You can see that port 1 is mode and status trunking native 1000. Since that S2, you can see that port 1 is on for trunking and native 1000. And for D, use the show Etherchannel summary command to verify the Etherchannel configuration. And then you can go for this one. Just type show Etherchannel summary. This is the list for the Etherchannel summary. You can see that group 1, you can see port channel is port 1, sorry, and protocol is LACP. Is the post switch for is the post port for the port channel 1. And since like S2, you can see the group 1 port channel is port channel 1, protocol is LACP, and this is the port that the port use. Okay, and then you can see that this PCA can send the data to PCB. Okay, to make sure the PCA and PCB is linked, we need to pin the PCA to PCB. Just go for PCA and pin for IP address for PCB. Just we show that the PCB sends 4 and receive 4 is the show that the PCA is linked for PCB. Okay, that's all for